The James Webb Space Telescope, also called Webb or JWST, is a large space-based observatory, optimized for infrared wavelengths, which will complement and extend the discoveries of the Hubble Space Telescope. It will cover longer wavelengths of light than Hubble and will have greatly improved sensitivity. The longer wavelengths enable JWST to look further back in time to see the first galaxies that formed in the early universe, and to peer inside dust clouds where stars and planetary systems are forming today. Please comment and let us know what you think of our videos. If you have not subscribed to our channel, please subscribe, so you don't miss any videos in future. The James Webb Space Telescope, sometimes called JWST or Webb, will be a large infrared telescope with an approximately 6.5-meter primary mirror. The telescope will be launched on an Ariane 5 rocket from French Guiana, and it launches on 18 December 2021. Webb will be the premier observatory of the next decade, serving thousands of astronomers worldwide. It will study every phase in the history of our universe, ranging from the first luminous glows after the Big Bang to the formation of solar systems capable of supporting life on planets like Earth, to the evolution of our own solar system. What was formerly known as the Next Generation Space Telescope, NGST, it was renamed in September 2002 after a former NASA administrator, James Webb. By viewing the universe at infrared wavelengths, Webb will show us things never before seen by any other telescope. It is only at infrared wavelengths that we can see the first stars and galaxies forming after the Big Bang. And it is with infrared light that we can see stars and planetary systems forming inside clouds of dust that are opaque to visible light. The primary goals of Webb are to study galaxy, star and planet formation in the universe. To see the very first stars and galaxies that formed in the early universe, we have to look deep into space to look back in time, because it takes light time to travel from there to here. The farther out we look, the further we look back in time. The universe is expanding, and therefore the farther we look, the faster objects are moving away from us, redshifting the light. Redshift means that light that is emitted as ultraviolet or visible light is shifted more and more to redder wavelengths, into the near and mid-infrared part of the electromagnetic spectrum for very high redshifts. Therefore, to study the earliest star and galaxy formation in the universe, we have to observe infrared light and use a telescope and instruments optimized for this light. Star and planet formation in the local universe takes place in the centers of dense, dusty clouds, obscured from our eyes at normal visible wavelengths. Near-infrared light, with its longer wavelength, is less hindered by the small dust particles, allowing near-infrared light to escape from the dust clouds. By observing the emitted near-infrared light, we can penetrate the dust and see the processes leading to star and planet formation. Objects of about Earth's temperature emit most of their radiation at mid-infrared wavelengths. These temperatures are also found in dusty regions forming stars and planets. So with mid-infrared radiation, we can see the glow of the star and planet formation taking place. Webb will be able to tell us the composition of the atmospheres of exoplanets. It will observe planetary atmospheres through the transit technique. A transit is when a planet moves across the disk of its parent star. Webb will also carry coronagraphs to enable photography of exoplanets near bright stars if they are big and bright and far from the star, but they will be only dots, not grand panoramas. Consider how far away exoplanets are from us, and how small they are by comparison to this distance. We didn't even know what Pluto really looked like until we were able to send an observatory to fly right near it, and Pluto is in our own solar system. Webb will be able to observe the planets at or beyond the orbit of Mars, satellites, comets, asteroids, and Kuiper belt objects. Many important molecules, ices, and minerals have strong characteristic signatures at the wavelengths Webb can observe. Webb will also monitor the weather of planets and their moons. Because the telescope and instruments have to be kept cold, Webb's protective sunshield will be blocking the inner solar system from view. This means that the Sun, Earth, Moon, Mercury, and Venus, and of course sun-grazing comets and many known near-Earth objects cannot be observed. Webb will be able to see what the universe looked like around 250 million years, possibly back to 100 million years, after the Big Bang, when the first stars and galaxies started to form. Please, let us know your views on the James Webb Space Telescope. Thanks for watching.